Welcome to my YouTube channel once again. This is, this video is about Fermat's last theorem for primes. Okay, so the Fermat's last theorem says that if ABC are co-prime, P is a prime, A power P plus B power P not equal to C power P. I will explain about ABC are co-prime later in this video. Okay, so you cannot find any integers ABC if P is a prime, or actually if P is integer, any integer basically. But now we are trying to prove Fermat's last theorem for primes in this video. We already proved Fermat's last theorem if P is even number. So now we are trying to prove for P is odd number and also for prime. Okay, so Fermat's little theorem says that if ABC, if at all A plus P plus B power P equal to C power P, then this implies A plus B must be C plus P multiple. Even that K1 is actually C1 minus A1 minus B1. That is accordingly Fermat's little theorem. Okay, so if P is a prime, okay, so we will try to see whether we can see whether this is the whole square for P equal to 2. For P equal to 2, A plus B equal to C plus 2K1. So if P equal to 2, this is Pythagorean triplets. Actually, P is a prime, P is greater than 2. So every prime greater than 2 is odd. So, but if P is even prime, that actually results in Pythagorean triplets. So take any Pythagorean triplets like 3, 4, 5, 5, 12, 13, 25, 24, 7, or 10, 8, 6, 7, 15, 8. Okay. The difference between A plus B minus C, first 3 plus 4 minus 5, that is 2. Okay, so 5 plus 12 minus 13, 12, 25, 7 plus 24 minus 25, 31 minus 25, 6. So you can always see A plus B minus C is even number, it's a 2 multiple. Take any Pythagorean triplets, you will always find this. Because we have Pythagorean triplets and we also have this formula like A plus B is equal to C plus P into something. Now in this case P equal to 2. So that means that you can, there is a proof, direct proof and verification that if P is a prime, P is 2, then we have A plus B minus C. If A square plus B square is equal to C square, A plus B minus C results in even numbers. Okay. Now we will try to see whether we can extend this A plus B is equal to C plus 3K1 for 3. Okay. So yeah. But the issue is that now since there are no integers which will satisfy A cube plus B cube is equal to C cube, so actually we need to prove that. So there is no verification there. But if at all, how we are going to prove is that if A cube plus B cube, if we can find some integer like C cube, then we will try to prove by contradiction. That is, well, we assume this and then we end up in some contradiction like 1 equal to 2 or something. Okay. So if A cube plus B cube is equal to C cube, A plus B equal to C plus 3K1 and C cube is equal to A plus B. A cube plus B cube formula is like A square minus AB plus B square cube is equal to a plus b. This can be written as a plus b whole square minus 3ab. So a plus b is equal to c plus 3k1. So c cube equal to c plus 3k1. C plus 3k1 whole square minus 3ab. K1 is equal to C1 minus A1 minus B1. That is, we can also derive that from Fermats theorem. What is K1? But for simple proof purposes, we can keep it as K1, which is actually C1 minus A1 minus B1. Okay. What this means is that if C cube is multiple of two numbers, C plus 3k1 and C plus 3k1 minus 3. Okay. If these numbers are co-primes, so the definition of co-prime is, since every number is either it's a prime or multiple of primes. That is the basic definition of any number. In fact, that is the basic definition of prime number as well. Either it's a prime or multiple of primes. So if there is no common prime numbers as a factor, for example, you can take 5 and 8. These are co-primes. Okay. So there is no common factor. 5 is only 5 factor. This is only 2 factors. 2, 4, 8. So since there are no common factors, common prime number as a factor, that means that they are co-primes. Alright. So now we need to understand that C cube actually is divided by C plus 3k1. So we need to get the formula of C if C cube divides C plus 3k1. Okay. So C cube by C plus 3k1 is an integer. Alright? So, let us take C is equal to product of two prime numbers P1 and P2. Okay? So, C cube will be P1 cube minus P2. Now, C plus P1 P2 plus 3k1 is an integer. Okay, so this denominator is either it can be P1 P2 or it can be P1 cube or it can be P1 square. So P1 P2 plus 3k1 is, let us assume that P1 into x. Okay. So that means that 3k1 equal to P1 into x minus P2. Now, that means that either P1 is equal to 3 or if P1 is not equal to 3, K1 should have P1 as a factor. Okay? If P1 is not multiple of 3, then x minus P2 should be multiple of 3. So we need to understand this kind of logic to prove that, to understand actually all this. Okay, so yeah. Okay, let us assume that P1 is equal to 3. Okay, so C will be like P1 cube, that is 3 cube. Cube. This will be like P1 P2. P1 P2 is what? 3 P2 plus 3k1. Then C is equal to 3 square P2 cube by C cube is equal to. Okay, so P2 plus K1. Okay, c cube by actually a plus b equal to a plus b whole square. 3 p2 plus 3k1 whole square minus p. Okay, so yeah, so then okay, again c cube by a plus b equal to 3 square p2 cube by p2 plus k1, that is also equal to 3 square 9 p2 plus k1 whole square minus 3ab. So you can take 3 as a common factor here, so it will be like 3 p2 cube p2 plus k1 equal to 3 into p2 plus k1 whole square minus ab. Okay, so since ABC are co-prime, C is multiple of 3, that means that none of A and B are multiple of 3. That means that this term, the right hand side, is not a multiple of 3. But left hand side we can see actually 3 is multiple of 3. Right? So that means that this whatever the P2 plus K1 we have should be multiple of 3. Okay? So again P2 plus K1 is equal to 3 into P3. Alright? So now, so what is C? Initially we assume that okay, what is C is 3 into P2. Okay? A plus B is equal to C plus 3K1. We are going to put all this in this equation. Okay, so okay, C cube is equal to 3 into 3 cube P2 cube. P2 is actually 3P3 minus K1. So C cube is equal to 27 into P3 minus 3P3 minus K1. And A plus B is equal to 3P2 plus K1. 3 into P2 plus K1, that will be like 9P3. A plus B is 9P3. A plus B whole square is 81. If A cube is equal to C cube, then we ended up in this formula. Right. Okay. So if you simplify this, 3P3 minus K1 whole cube by P3 equal to 27 P3 square minus AB. Okay. Now, if you see this term, CP3 minus K1 is divided by P3. What this means is that K1 is either K1 and P3 should have a common factor in this. That's all. What this means is that. Okay, so let us assume that K1 and P3 have the same common factor P4. Because when a cube divides some number and then that number is 3P3 minus K1, so that it should divide also K1, at least there should be common factor. That common factor, let us assume P1, P4. Okay? So K1 is equal to P4. Okay, so yeah, P for K4. Alright, so P3 is equal to P4. Now, alright, so P4 into something like yeah, P4 into X. Okay, so next 3P3 minus P4 K4 whole cube by P4X equal to something. Again, P3 is P4X. So and P4 cube 3x minus K4 whole cube by P4x. Okay, again P4 gets cancelled, P4 square. Okay, that equal to, again, this is an integer. Alright, so again 3x minus K4 divided by x, right? So again K4 is x into something. So this entire this entire exercise will be going towards, it's like it is like infinite descent. Infinite descent means this is exactly the, so everything is kind of going downwards, and then it is kind of impossible to prove that C cube is equal to, there are no integers basically if C cube is equal to A cube plus B cube. Alright, I'm going to explain this further in my next video. Thank you very much.